Hello, everyone, and welcome to episode 4 of Serverless Sorcery. I'm your host, Rinaldi, and today we've got a treat for all you serverless enthusiasts out there. We're diving into the magic and mysteries of generative AI and serverless architectures, and this week on how it is used for tailoring the doctor-patient experience and providing better therapy adherence through empathy. We have a pioneer in the field today, Luca, to talk to us about this. Luca is the CTO and R&D manager at Neosperience and Neosperience Health, and an AWS serverless hero. So without further ado, let's get started and unravel the enchantment behind serverless. Luca, welcome to the show.
Welcome, thank you. Thank you for having me. It's a pleasure to be here and share a bit of experience.
That's great to hear, Luca. How are you doing?
Yeah, I'm doing fine. It's a quite cold winter approaching here in Italy, but that's fine.
That's fair. We're actually just entering summer about now, so that's a bit of a polar opposite right now, but it's settling soon. We're getting a bit of like rainy days as well, but weather's like
You are
pretty good
luckier
too.
than me because you are approaching summer. We are approaching winters.
That's fair. We had a pretty bad winter here over here. We have a great theme today to talk about, Luca, and I'm really excited to talk about what we're going to talk about today about what you're doing in the field. And to get us started off with, do you want to talk a bit about like what you're currently working on and what topic we're going to talk about?
Yep. We are working on health. We are working into applying AI to the health domain, and also working how figuring out how serverless technologies can provide an additional value, so additional benefits for developers when you're doing AI, especially using LLMs.
Right. And for that, what particular FMs have you played around with, and what particular use cases have you gotten out of using the FMs? Like, have you been using? I know you've been using Amazon Bedrock, for example, but like any particular use cases you got out of that so far yet?
Yeah, especially we aimed to change the way doctor and patients are communicating. And it is something where I think that an LLM could be really helpful. Because one of the main problems that you can face when you talk to a doctor is some kind of lack of knowledge that a patient has every time that has to process medical information. So medical information are just merely facts. So when you have a medical text, it is a fact. It says that your platelet count is blah, 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 or that your cholesterol is of some kind, and so on and so forth. But when you go to the doctor, you ask the doctor to explain that fact. So you ask to the doctor basically, if you see that, if you look at a marketing purpose, you ask to the doctor to put the storytelling on that fact. So basically, one of the most underrated capabilities of a good doctor is to be able to explain clearly. So to tell a good storytelling to their patient to make them understand correctly what's happening. Because sometimes you can have irrelevant facts. So say your cholesterol is just slightly high. Some other times you can have some very relevant facts that require you to take further deep divings into your clinical text, or maybe to adhere to a therapy. And the way how doctor communicates to patients can change dramatically the adherence to therapy. So you can underestimate, undervalue what the doctor is telling you, because basically the doctor is using the wrong words. The wrong words. So basically, it's not stressing enough the importance, the relevance of a given therapy. Or maybe you can be frightened because maybe a doctor just tells you all the bad outcomes that your schedule procedure or your therapy or the lack of therapy could lead to you, but maybe your situation is not so bad. Just let me give you an example. Think about biopsy results for every patient. when you read a biopsy result, you can say, okay, there is some kind of cellular level which significant phlogosis, or maybe blah 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 blah, and it is completely obscure to anyone which is not a doctor. And you go to the doctor, and the doctor tries to explain that to you. But unfortunately, the problem that we are facing in Europe, but it is, I know that it is something which is quite diffused worldwide. So this is a problem that we are facing pretty much everywhere, is that in this after pandemics world, doctors tend to have don't have too much time to deal with these results. They are overwhelmed by screening. They are overwhelmed by people needing for medical care. So it is very difficult for doctors to find the right time, to find the right amount of time to deal with patients. And on the other side, it is also something that could not be related to the way a doctor is trained. So you train doctors into becoming good medicians, into becoming good professionals, into being able to do surgery, into being able to find issues and find medication and find solutions to patients. But very often, doctors are not trained enough into talking to patients, into using the right tone of voice, and also into changing the words that they are using respect to the person that there is in front of them. So if you are talking to, say, a 20 years old medicine attendant, you can use some kind of wordings. If you're talking to a 70-year-old man coming from the islands, you need to use a different wording, a different tone of voice to achieve the same results. We find out that LLMs, that foundational models, are pretty good into modulating, into changing, into adapting the wording. And we push them even further because we discovered that they are really good into understanding the medical results, understanding, even in the biopsy example, into understanding the meanings, the terms of the biopsy, and then rearranging them into a tone of voice, into a speech that could be easily understood by people. So our idea was, why not use these tools to suggest the doctor the right information at the right time for the patients? Because otherwise, a patient is going to Google that result and to find out a lot of stuff that he or she cannot process, and it could be harmful for everyone. It could be harmful for them. It could increase the level of stress. So basically, this is the idea of Neosperience Health when we say we are putting empathy in healthcare, because empathy is what makes people, it's what drives people into having a good relation with their doctor, into following their doctor advice, and it prevents also the doctors from burnout. A close friend of mine who is a doctor told me once, you start studying medicine because you want to save lives of people, and then you end your career that you hate everyone, especially patients. And it is due to the fact that doctors need to focus on a lot of stuff that is not related to saving lives, is not related to dealing with patients. And it takes doctors to burn out. And when a doctor is undergoing burnout, it is underperforming, and one of the most difficult things to achieve is to talk to patients, because it doesn't want to talk to patients, it doesn't want to deal with them. And here is where LLM foundational models can be helpful. But we need a bit more on that. So we will discuss shortly. Just LLMs are not enough. we need to put some kind of architectures in place in order to address these goals, because we need a way to store the previous information, a way to allow doctors to check if the generated result is enough or not, a way to read PDFs, and so on and so forth.
Definitely. That's a really great case, Luca, for what you've just said. And I'm already used as well to going to hospitals and often have time finding the right stuff to read to. So that's a really great thing that you're building towards. And as you mentioned as well, I do feel that it's a great way to prevent doctors from making errors as well, because there is always the tendency when doctors are more tired to make lapses in judgment for decisions that they provide or explanations that they provide to patients. So I think you touched on a really great point there. So moving on to what you were mentioning as well about the architectures, I'd like to touch on that point. Can you talk a bit more about what particular architectures you're currently putting in place to establish these guardrails for these foundation models you're currently deploying? Like, are you particularly using any packages or functions currently within that to be able to ensure that the core architecture is moving well? And how is the serverless architecture designed?
Yeah. So the architecture way that we choose is basically 100% serverless architecture, because we found out that one of the needs that we had to face was the capability to scale up and down very quickly, and also to be able to compose our architecture with different models. Just let me explain a bit more about that. Usually, when you put foundational models into works in real use cases, it is not enough to just use a standard input. So basically, a direct prompt, send a prompt to Bedrock, and then get back to the results. Usually, it doesn't happen this way. This is due to the fact that maybe in real life use cases, you need to do a bit of back and forth between you and the foundational model, between you and Bedrock, in order to get your result processed. Let's step back to the biopsy example. When I provide a biopsy document, basically I have a PDF of the document. So I need to upload that PDF somewhere, which is basically the easy part. Then that PDF needs to be processed. So it needs to be indexed anytime, in any way. The information, the written text need to be extracted. And then I need to pre-process that text. So I need to extract from the text a brief summary about the content of that biopsy. But on the other side, I need to process a knowledge base, and from that knowledge base, I need to extract related information, and then I need to pack them into the same prompt. And after that, I need to use that prompt to provide a feedback to the doctor. So basically, in this very simple example, I'm using the foundational models almost 3 times, at least 3 times, because I'm using the foundational model to summarize, 4 times, because I'm using the foundational model to understand the content on the biopsy. So I need to craft a prompt that says, explain each one of the terms mentioned in that biopsy. Then I use the foundational model to summarize. I cannot do the same thing. There is a very nice paper which is called React Reasoning and Acting. And I suggest you all to check it out if you haven't done before, because it is a paper that explains that foundational models are really good into performing reasoning and understanding and detecting the kind of actions that you need to accomplish, but you cannot do both in the same iteration, because otherwise the models tend to derail. So we can use the model to reason and to extract the information, then the model to act and summarize that information. After that, we need to use the model to retrieve information from an external knowledge base, maybe an authoritative knowledge base dealing with medical information. And then we need to craft them into a prompt and compose the prompt to make the model, the foundational model, generate the outcome, so the suggested explanation to the doctor. So basically, we are using a model 4 times. It is not affordable to do that without a framework and without an architecture. So on the architectural side, we need something being able to be composable. And one of the most appreciated features of serverless that we experienced in this domain was, curiously, it was not the scalability. So the scalability was point number two. Point number one was composability. So the capability to use to think about serverless as a set of composable modules in which even your functions are something that can be used to compose different use cases. So flexibility at the end is something that it is really relevant in this domain. And we appreciate is using CDK to compose the architecture. But also we evolved that into using CDK to provide a set of different functions implementing different units of computation, each one of them with its own foundational model usage, and then using technologies such as step functions to coordinate that. At very first instance, it was super fine. But after that, we found out that step function is good to process state machine when you have to deal with traditional computation. So you have to manage file uploads, you have to manage doctor approvals, and so on and so forth. And it was super great, and we used that. But after that, we needed something more to coordinate, to orchestrate the usage of the LLM part. So when you are dealing with the URLM within a single Lambda function, so basically we are using AWS Lambda as our computational unit, even within the single Lambda function, you need to compose many different blocks, and you need to invoke and use many different services. So the architecture, the CDK architecture, is going to provide you the modules that you need, but it is within the function that you have to orchestrate them. And luckily to us, there is an excellent framework, which is named LangChain, that provides all the support and all the abstraction that are needed to model the working with LLMs. So it provides abstraction for memory, it provides abstraction for prompts, it provides also the abstraction from chains, where chains are predefined composition of different modules. LangChain is a framework that you can leverage either in Python or TypeScript, but my suggestion is to check out the Python version because it is the most up-to-date version. So often new releases are released in Python and then backported to TypeScript. But if you are comfortable with TypeScript as well, you can use LMs and you can use LangChain even with TypeScript. And the best part is that you choose the abstraction model. So you say, I need a memory. You say, I need a prompt. And then you can use the right plugin to specialize that abstraction. So when we say we need a memory, we can easily switch from DynamoDB for storing conversation, because sometimes you need to have your doctor refine the prompt. So they suggested a message. So I provide a message, and the doctor needs to write back, okay, make that shorter, or avoid mentioning that kind of topic. And the model needs to have a very short memory. So we are not doing a conversational chatbot, but we need to support memory in order to keep a window of messages in order to let the doctor improve the quality of the outcome, sending messages to the model. And we can use, so we need a component that is able to express memory. And we found out that DynamoDB is a good choice. Other pretty great choices that can be considered when you are facing scalability, and also when you are facing the need to have to control your throughput, which can be tricky with DynamoDB to provision the right amount of throughput. And otherwise, if you use the on-demand option, it could be it could lead you to unpreventable cost spikes. You can also choose to use cache solution, and you have plenty of caching options such as Elastic Cache and so on and so forth that are mapped using the memory abstraction, and that's pretty good. And even to process documents, even to process data, you can use chains. Chains are predefined compositions of models, some of them using LLMs, and they are excellent to say process a PDF into extracting and summarizing the result of the PDF. But more than that, you can use LangChain also to abstract away at some point the model that you are using. Just let me super clear. You cannot abstract that away completely, because when you deal with prompt engineering, each model has different edge cases to manage. So crafting a prompt for Titan is not the same thing as crafting a prompt for Claude, which is different from crafting a prompt for GPT-4, because you have to deal with nuances which are different in each one, but you can basically improve a lot your prompt management using LangChain, which can abstract away also the noisy part of being able to call directly Bedrock APIs, then manage the connection to that APIs, and blah, blah, blah. You can use the component, and then you can provide your prompt, and then your duty, it is about crafting the right prompt, or maybe adapting the right prompt. On the prompt side, LangChain provides a lot of capabilities related to string interpolation and being able to enhance and compose even complex prompts. And more than that, we found out that LangChain is also great to be extended. Right now, we are extending LangChain with a token counter. So we are writing a plugin. It's just a bit of a spoiler, but we plan to release that open source once that we have done. We are crafting a plugin which will be able to count and to keep count of the tokens that you are consuming, and to store them in order to provide you a best way to manage your LLM usage bill, because since they are priced by thousands of tokens, and the number of tokens tends to be very different from interaction to interaction, because it counts all the messages and all the previous messages that you have sent back and forth. It could be a bit unpredictable to find out the right amount of tokens. So being able to keep track of them could be useful. And on the other side, we have been using LangChain into testing the model. And but maybe something that we will discuss in a bit when we are talking about how to check that, how to keep the model in check.
That's a really great case, Luca, and I think you touched on a lot of great points of the architecture really well. It's yeah, I feel like a lot of our listeners who are already using Bedrock definitely already had an encounter with LangChain, so I hope it's been working out well for you too. I've personally found it very good to work with, and it's very flexible. A lot of things are already there, and like you mentioned, one of the most powerful things that it's able to do is it has the capability of maintaining context, which I feel like a lot of other libraries currently are still struggling with. So it's a really great thing that you mentioned that. And one of the things you also touched on that I feel was resonated well with me too was a bit about how different FMs currently also respond differently based on your prompts as well. I think that's a good point to touch on for our listeners as well, because I've experimented with it a bit, and one of the things, for example, I was like finding out was that Amazon Titan had a more neutral way of looking at things and tried to stay as neutral as possible and objective as possible compared to a lot of other FMs, for example. And one of the ways that I was thinking about was how can I try to make it a bit more opinionated and be more creative, like say Claude, for example. So I think you touched on that very well too.
Yeah, and there is also something that you should consider is that the size of the contents matters, and it doesn't matter only on the way in the way that everyone thought. So shorter context is shorter cost, harder cost context constraints are worse than longer context is support. Because we recently find out, so not we, but the scientific world find out recently that the model doesn't process the context, every part of the context in the same way. It is something astonishing, but if you think about the architecture of foundational models and the transformers architecture, it becomes pretty clear. Basically, the problem is that longer contexts are not always better than shorter contexts. This is due to the fact that the model tends to focus more on the beginning and the end of the context and provide less weight, less important to the central part of the context. The thing that we found out almost empirically, and then a paper came out, say, I think 3 weeks ago, measuring that, is that the weight that the model provides to the beginning part or the end part of the context, it is far more relevant, far higher than the weight that it gives to the central part of the context. So if you are basically putting a lot of stuff into your, say, 64Ks or 1000Ks context, you are basically ignoring a lot of relevant part of your context because they are basically in the middle of the prompt, in the middle of the context. This is pretty clear if you consider that the attention mechanism of the transformers tends to focus more on the relevant part of, say, a text, which are basically at the beginning or at the end of the text. So it's something that is in this way by design, but prevents you into crafting longer context, even if the models is able to support that. So Claude 2 is able to support longer contexts. A lot of other models, such as I think Coral from Cohere, supports even longer context, which is pretty good because you need to pack all the back and forth with your model, but you need to consider that while you are making your context longer, you are losing information. So you are losing focus on the middle part of the context. So you need to optimize also for that. Sometimes, even if your context length support that, you need to summarize some parts of your context and then fill that summary instead of using all the information, all the data that you have in order to keep the model more focused on your information. It is especially true when you deal with RAG, which is Retrieval Augmented Generation, and where you tend to have within your context all the information that you retrieve from an external source.
Right. And I think you touched on the next point that I was actually going to bring up, Luca, which is basically in regarding RAG. RAG has been a big area that's been growing recently as well in regards to being able to act as a question answer source for a lot of documentation. And how have you been applying RAG as well? Like, have you been seeing like much of a sort of a use case from it as well?
Yeah, RAG is a technique that has been used, I think, since even before that LLMs became so cool, because it is a technique that is basically based on results from BERT and distillBERT and GPT-3, which basically uses a capability that these models have, which is related to being able to craft embeddings from the text. So basically, it's not just only a capability, but it is one of the mandatory parts of the working of the model. So every time that a foundational model needs to process a text, the first step of processing is translating that text into a numerical representation. It's an array of numbers that maps the semantic distance of each term from the others. And this array of numbers, it is called embeddings, and it is the real input to the model. But we found out that this numerical representation of semantic meaning is also great for searching a database. So we started building a number of vector databases. If you look around, you have plenty of that. So pretty much every week, a new vector database is released. Also, just to point out, when I say we, I refer to we as the engineers, we as the data scientists, we as the collective of people that are working on this model, not just me. I won't be able to build a vector database from scratch. But we are luckily to me, we have plenty of them. We have also solutions within AWS, such as OpenSearch, which is supporting vector indexing. Then we have Momento. Then we have MongoDB, which is going to support vector searching into the database. And we found out that all of them are able to retrieve data which is semantically close to the text that you sent as an input to the database. So basically the idea is I can encode all my knowledge base, say about our use cases. We have doctor knowledge bases, we have medications information, we have a lot of information about supplements. We can encode that using embeddings, then store this large amount of information, even much larger than any prompt sites that we can craft, and store that into a vector database. Then we can use the same technique when we receive a question to encode the question and to extract information which is semantically close to the input question. Then we can pack that information into the same prompt, into the same context, and then ask the model to use that knowledge to craft an answer, to craft a specific information. A couple of minutes ago, I told you about the fact that when we process the medical result, we need also to look up for information related to a condition. So if the condition is, say, some kind of medical surgery, maybe you are providing information about medical surgery, you need to look up into your knowledge base about what do you mean with that. Or if you need to provide information about, say, about medications, about drugs, you need to look up into a vast knowledge base about them. And the way you can do that is using RAG, and then you can extract the very short bit of information that you need. So basically the closest one to the topic that you are discussing about, and you can fill that into the context in order to provide the model all the knowledge, basically a cherry pick of knowledge that is needed to the model to provide the right information. And it is one of the most used techniques, and in my opinion, is something which is quickly becoming a commodity. I've seen a lot of out-of-the-box solution, out-of-the-box libraries in just the last 2 months trying to provide the full end-to-end solution for RAG. Even line chains has a lot of chains focused on RAG. So it's something that is becoming the building block of any LLM application in the close future. And it is one of the most powerful tools that we have in our toolbat, beside newer techniques such as agents that can shape the way we build LLM applications.
I think it's a really great thing that RAG is becoming more and more looked at with the evolvement of Gen AI. I myself have been playing with a lot of RAGs recently as well for trying to put into my documentation base, and that's particularly one of my use cases as well. So I think it's a very interesting thing that you brought up, particularly with your own use case of that as well. And I think it's just shows like how powerful it is to be used by any knowledge base, really, because of how it can eventually be able to just query things easily that way and save a lot of efficiency and make a lot of efficiency by saving people time by actually doing like that kind of search and letting Gen AI instead do it for you. And that technique combined with the technology we have from Gen AI right now is really a big thing that we have moving forward. And I'd like to move the conversation a bit now towards the regulatory side of things. So, one of the things I always heard about within the medical industry is always regarding regulations, because we have things regarding PII, we have stuff regarding how doctors should carry out certain procedures. I wanted your opinion as well. How are you finding this treatment of PII and regulations, particularly within the your industry, and how is it affecting as well how you are carrying out your work with generative AI?
Yeah, it's a good point because especially in healthcare, I think in almost every domain, but particularly in healthcare, regulation is very strict, and I think that it is good because when you are dealing with medical conditions, when you are dealing with people, you cannot afford to have so many errors. You cannot underestimate the kind of issues that you can have. So uncertainty, which is something that could be intrinsically built into foundational models, it is something that you cannot afford to expose to patients. You have a couple of regulatory issues to deal with. The easiest one are related to redacting PIA. I think I say the easiest because models, such kind of models, are pretty good into detecting them, and we are just close to having a lot of solution related to PIA redacting, and in many cases, information is not needed. That information is not needed, and it can redact it even before sending the data to the model. Sometimes it is not actionable, and this is the reason why you have to move further and try to understand which solution is good for you. Let me be a bit clear on that. No one except for cloud vendors can afford to train and deploy LLM. Someone can afford to just deploy a pre-trained LLM, but even fine-tuning is going to require a huge amount of investment. This is the reason why I think that definitely the cloud is the preferred solution, and it will be the preferred solution for many of us. Pretty much everyone out there will be able to leverage foundational models using directly a cloud vendor, a cloud provider. And being able to choose the right model, being able to choose the right conditions that you can have in terms of data management, data privacy, it is something that could be helpful because these models are going to process relevant data. But it is not enough because on an higher level, you also need to be sure to ensure that your model is not misbehaving in the results that it is producing. And in this case, such as healthcare, even an error of, say, 1% means that to one person out of 100 people, you are telling the wrong thing. And the wrong thing could be harmful. So, in my opinion, these tools are pretty good, but you cannot use them directly and expose them directly to people. You need to keep the human in the loop. The human in the loop, it is someone who can filter your results, your LLM results. He is someone that can improve the quality and prevent errors. So our idea is to make the human work easier, is to speed things up. You mentioned before that to doctors it is quite difficult to keep up to date with the large amount of data that they need to process. Consider about dealing with patient data. Usually, a doctor to provide a good decision doesn't need to collect all this vast amount of data. If you go to a cardiologist need just to understand a small subset of parameters. So it doesn't care that you have gone to, say, ankle surgery 2 years before, or that your relatives have some kind of genetic illnesses, or so on and so forth. Because to do their job, they just need to focus on few information, and we can provide this right amount of information, but we need always to have people in the loop. And more than that, we use people feedback even to improve the behavior of the model. We have been successfully into building chatbots that can be used to test chatbots. So we have been successfully into using GPT-4 to test a Claude chatbot. So the GPT-4 chatbot had the task to try to trick the chatbot into misbehaving. And we had the human judge the result and improve, and not improve directly the chatbot, but improve the tester, because improving the tester, it is easier than the testing every edge case for the chatbot. So say, if I am a doctor and say, okay, you don't have to mention, say, you don't have to mention cancer if a patient doesn't have any clear diagnosis about cancer, because it can be frightening. I can provide this specific instruction to the testing chatbot, and it can generate a number of dialogue to the chatbot that I want to test, in order to make that misbehave and mention cancer, even when it is not relevant, even when this is not true. So keeping the human in the loop not only ensure that you are sticking to the guardrails, but it also can improve the overall process.
Definitely. I completely agree with your point of keeping the human in the loop, because I've already lost count of how many times I tried actually putting in a particular prompt into ChatGPT or Bedrock, like, yeah, whether it be Claude or Titan. There's always going to be cases of hallucinations that's just like not going to be gone anytime soon. And I feel that with, the how many updates there are to the models, it's going to continually become a big thing and continually become a thing that you should look out for. So 100% on that. And yeah, I agree that one of the best ways to see its limits and just test out how good the model is really by doing some chaos engineering, like you mentioned. Just try to make it make mistakes. And yeah, I think that's a good note as well to our listeners too. Like, try to see its limits and accordingly refine based on that, but always keep the human in the loop, as you mentioned.
Yeah,
But that's yep.
and having human provide feedbacks to testing, to ways of testing the chatbots, to ways of testing the prompts, it is something relevant because we need to build tools to test chatbots. Because every time that an LLM is retrained on a different set of knowledge, its balance can shift. I've seen countless papers talking about how the accuracy of GPT-4 changed from during the last 12 months, because basically it was retrained, it was fine-tuned, and every time that you retrain a model or fine-tune a model, the accuracy changed. It could improve. It could improve on some fields. It could globally improve, but locally be worse because testing on a complete different set of knowledge, it can be a bit tricky. And we found out that sometimes locally on a specific domain, it gets worse. So having a chatbot that can be used to test and to craft different edge cases and detect different edge cases, and have a domain expert able to judge if the answer is good enough to be acceptable, is something that can be used from time to time to keep the model in check, even when it goes under retraining.
Definitely. I think that's a really great point as well. But Luca, we're a bit of out of time, but we'd just like a close up. So I was wondering if you had any closing remarks you had to our listeners for anyone who wants to explore further about Gen AI usage within healthcare.
Yeah, I think that's one thing that is going to explode in the next few months. It is all the agents topic, all the agents stuff, because I think that pretty everyone have seen the video about OpenAI Dev Day when they presented agents, and I think that this technology, which is, by the way, supported by LangChain, even with different models. So agents are nothing new to GPT-4. It is a technology. Maybe GPT-4 makes them easier to be used, but it is a technology that LangChain support, and I think it is something that could even improve further also the diagnosis capabilities of this stuff. So with agents, you can provide the context, you can provide the APIs that are needed to the model to interact with the environment. Maybe you can provide APIs for different knowledge bases, for different source of truth, and you can have the model follow that react mechanism that we discussed before in order to find out the best solution, and then craft down the steps to achieve that goal, and then actionate them into building the goal. And this could be super helpful to doctors, because it could help them to think out of the box, to think about topics that are not under their field of expertise, and maybe provide different diagnoses. I've read a scientific paper published on Nature a couple of months ago. It was related to long COVID diagnosis, which cannot be made by a set of doctors visiting a patient, because the reason was that it was a systemic diagnosis. So if you look just to the liver, just to the lungs, just to the heart, it is quite difficult to diagnose long COVID. And every doctor was looking to their specific expertise, but once they used an LLM to put all their knowledge within, it came out with a suggestion to test for the presence of specific cytokinin or EGA within the patient blood, and it was the solution. And so it is something that could dramatically change the way we work with doctors, and it could dramatically improve in the near future. So my suggestion is to start easily, start using prompts just to process data and to provide data summarization, then step up with RAG, and then start testing with agents, because it is a super powerful technology that I'm sure it will be used in the near future pretty everywhere.
I feel that all those techniques will be very helpful to all our listeners, Luca. I think you really highlighted as well that it's just amazing sometimes, like thinking about how generative AI has been able to provide us insights that we might actually not think about before too. So it's definitely a very powerful tool that will continue building and developing. But again, I feel it's a good way to summarize it is it's always good to have it around, build architectures around it, but at the same time, never let it go completely autonomous, especially like an industry like healthcare, because you never really know when it might give you the error or the wrong answer. And basically in an industry like healthcare, it can be really costly to make that one small mistake. But that's pretty much gonna wrap up there. Luca, thank you so much again for your time today on the podcast episode and for sharing your expertise and experiences with all our listeners today. And I'm sure that our listeners have managed to take away some very valuable insights from them. So, as usual, to listeners, if you want to stay up to date with Serverless Sorcery has to offer, do follow the LinkedIn page at Serverless-Sorcery or my LinkedIn at Ronaldo Gonesperto. And you can reach Luca at Twitter at Bianchi Luca or LinkedIn at Luca Bianchi Pavia. And again, thank you, Luca. Thank you again, folks. And we will see you in the next episode.
Thank you very much for having me. It has been a pleasure. Thank you all for listening.
Thank you all. Bye.